The next challenge is metacalc. This was a 498 point challenge and 6 people solved it. I did not solve this challenge during the CTF, so I referred to write-ups afterwards. The 4 write-ups I looked at were one from the challenge author here by Seraphin, and they go into depth and they talk about what the real solution was supposed to be, but the other 3 write-ups did not use this solution. I also referred to Maple's solution, Maple3142, the URL is here, and then 2 people on Discord, Strelic and Applet, also had write-ups. But anyways, back to the challenge. It says, I ran into this awesome Node.js spreadsheet library using some custom sandboxing, so I tried it out. I even hardened it a bit more. Nothing could ever go wrong. We're given a netcat port and a zip file. If we look at the zip file, we're given this app.js file, so nice and small. It's going to read, it's going to map input and output, and then it's going to say, I will add one to your input, and then it's going to create this sheet object, which is, I guess, the metacalc, and it's going to add our input, it's going to do equals equals, and then it's going to log out the values. So step 1 was just seeing if metacalc had any CVEs, like this is the entire challenge. Oh, and they also give us a patch, this patch. So the challenge author said they hardened it even more, and the hardening was adding this if prop equals proto. I'll talk about this in a second, and also removing math. So 2 things to talk about. First, so what is metacalc? This is like a JavaScript library for creating a Excel sheet. So you can like set table values into equal expressions. So you can kind of see here. So we have a sheet. We're referencing a cell just like in Excel or Google Sheets. You're giving it a value. We're doing an equal sign. We're setting 2 things equal to each other. So it's just a JavaScript way to do Excel. They reference that they hardened it even more, which makes me think that there was a previous CVE or something, and it turns out there was. I'm not sure when this was. Where's dates? Well, here's May 15th. But in the metacalc package, it says prevent arbitrary JS code execution. Apparently someone premier submitted a issue. And there was some back and forth on the actual solution, and there's a pitfall, numbers, looks good. And if we look at what the actual fix was and what the issue was, prevent arbitrary JS code execution, they introduced this new wrap thing. So it looks, and this proxy thing, which we'll talk about in a second, some test. And it's nice that they added test, prevent arbitrary JS code execution. So it looks like the old exploit was doing math, constructor, and then arbitrary code execution. So they were, I'll talk about this construct in a second too, a lot to talk about. But it looks like they were able to get code execution from a couple of different methods. One thing to note, the reason that exploit worked, so you're allowed to execute arbitrary JavaScript in these cells, like you can see. I mean, this is essentially doing an eval, but what's happening is it's actually being executed in this like meta VM. Where is it? We can't see it here, but there's another package installed called meta VM. The metacalc, it depends on meta VM, wherever it is. And so this is some like virtual machine sandbox sort of thing. So ideally you wouldn't be able to escape out of the VM. And this challenge wasn't about escaping the VM, it was about finding a bypass for their fix. I assume this bug will probably get a CVE, so there was this fix, and then I assume the new fix should also get a CVE because it's also code execution, but we'll see. So the original fix that didn't fully fix it was this. So the author, like the real author of the package, they added this wrapping thing so that sorry, let me back up. So again, it is a virtual machine, and ideally we can't escape from it. But in the original exploit, they were able to escape because one object is exposed outside of the VM, and that's this math object. So within the actual like sheet, this is sheet.js, there's another proxy for get value. And so normally every other value when you call like, I don't know, my object.py or something like that, or my object.value, it'll stay within the VM, but there's like this little proxy thing that'll see if you're calling math. And if you're calling math, it'll return the top level math object. And so you're kind of escaping the VM. And I think this is the only object that allows you to escape the VM is this math object. And I mean, you need the math object because it's like, it's a sheet calculator app. You might need to do min or max or, ceiling or whatever math function you need. So the original solution was to use a JavaScript proxy. And so this is like some JavaScript object. They're pretty neat. I could see this could be useful in a couple different contexts, but basically it's like you put this wrapper around the object and you can introspect its like get and set function calls and other stuff. And so we need to figure out a way to kind of bypass this proxy, because the proxy, where's the code? The proxy is going to check that if you do a get on an object that's wrapped with this proxy, and the get property you're looking for is constructor, it's going to say no. And if then it's going to get the value. And if the value is a number, it'll return the value. Otherwise, it's just going to go down another layer. So you can imagine asking for a.b.c.value or something like that. So it'll kind of copy down. And so we're no longer allowed to access constructor. And so the original author of this package, they wrap the math package in this proxy. And it's pretty hard to bypass this proxy. And so the original person who reported this issue, I guess, signed off on this. Yeah, they continued. And yeah, our job was to bypass their fix. So the challenge author of the CTF also mentioned that they hardened it even further. So I guess this would have been too easy of an exploit, especially with the proto was still on the object. That's nice. So if object is equal to constructor or proto, it's going to return null. And they also got rid of the math object. It says math has too much of an attack surface, sad face. And so instead, slightly less useful math is just a blank object, and then they wrap a blank object. So obviously this makes the calculator app almost worthless. Well, you can still do like plus and minus in the VM, but you no longer get math. Cool. Like I said, I did not solve it during the CTF. So instead I had to look at the solutions that other people wrote. I tried a whole bunch of different stuff. I knew we needed to escape that proxy somehow, and I was reading like, we have an object. And so if you go to like the JavaScript docs and you like look at object, like object.keys, like I was trying a bunch of different things like define properties, and I think it was like get own property descriptor, but eventually I wanted to, so one of the goals, like I said, something that's interesting. So I know this from, backing up again. So for arbitrary code execution, obviously you have evals. I wonder if they have CSB. Oh, they have CSB. Who doesn't have CSB? Actually, we'll just do a terminal. Cool. Can we clear? No. I'm just going to scoot this up a little bit. All right. So obviously you can do an eval. And I think most people know that, you can put whatever you want in here. Like this is code execution. A slightly, maybe less known eval sync is actually a new function. And so you can actually eval in here. So like if we were to do, let me do return. You can see this is the same as eval. We're just wrapping it in a function. One thing that's cool is, I think, is this 1 + 1? So nope, I guess not. But if so the default constructor for an object doesn't look like the eval thing. But if you do constructor.constructor 1 + 1, we are back at a eval. So apparently the constructor of the constructor allows this arbitrary eval sort of syntax. And so we can just go up the constructor chain until we find a constructor that is based off of this new function construct. And the same happens for math. And so this was the original exploit. Cool. Forget what I was going to talk about that. Oh yeah, and so when I was trying it on the CTF, like I was trying to find different ways to like get the constructor, but I couldn't figure anything out. I was looking if there were like proxy bypasses, but that's not like a common thing you would want to do, to like bypass a proxy. So played with it for a couple hours. I didn't make it. Like I said, there were 4 solutions. The challenge author had one using getters and setters, or making your own getters and setters, which I'll talk about. And then the other 3 solutions were based off of this thing. Basically, they boil down to this get prototype of. Cool. But let's go through all of them. So I modified the sheet.js that was given to us. So this is within node modules, metacalc, lib, sheet. So this is within the actual library, and I added a couple of console log statements. So I added one at the start of the wrap to see what the target is, and then I added a console log here whenever we do a proxy.get, so we can see what the target is in the prop. And we can start playing with the different things that happen. So just to get kind of a sense for what's happening. So we're going to imagine that this is our input, and so eventually when we want to submit a solution, we're just going to submit this. This is going to run in the Docker file that was provided, so everything is the same. It just allows us to play with things faster. So we can imagine that this is our input. So if we were to run this, node, I think this is solve.js. Some reason it's not happy. Oh, that's because constructor is null. Cool. We can see math.constructor is null. And this is our return right here. So we can see a proxy object was created. It's doing a proxy get on the math object. Math object, if we remember, is now just an empty object because of the patch. So slightly less useful math, new object, just an object. So that's why proxy.get is getting the math, which is just an empty object, and we're asking for the constructor. And the constructor, because of the new proxy logic, is null. Anyways, let's just change this back to math. So now we're going back to the math object just to see what happens. So if we do math, yep, we get a math object, and now we can do math.py. And so the calculator, this is what the actual library works like. So we're getting math.py. And so we can see, like I said, we're doing get object, so it's going to be math pi. It's not constructor, it's not proto, it's going to get the value, it's going to see the values of type number, and it's going to return the number. I think you can also do like math.ceiling and stuff like that, and you get back the actual functions. But cool, okay, so that's working. Let's go back to what our challenge looks like. Like I said, there were two different solutions. The first solution was this one. So they create an empty object, then they call the constructor on the empty object. This exists within the VM, and so it's not, it doesn't have the proxy object on it. This is just within the VM, and only the math object actually has that proxy on it. So we can call constructor on this, and it doesn't really matter because it's just within the VM. There's no escape. But there's this neat function call, get prototype of, and then math. So this call doesn't actually it does the proxy.get call, which we'll see, but it happens too late. We can't actually see it here. I'll show the full exploit in a bit. But basically, this is the key piece of information right here, is you can get the prototype of math and then start calling out the constructor. And so if we see, this was one of the write-ups. So constructor get prototype of math, then you have the real math prototype, and then you can do constructor because the proxy object no longer exists on it. Somehow this bypasses the math proxy, but then you can call constructor, return process, and then the rest of the actual exploit is just kind of generic. So once you have process, then you can do main module, and then just require and start calling system calls. So that was solution one. The other solution was the one that was intended by the challenge author. And so in this one, they actually define a getter, a new property on math. And so their logic was, you can define a getter such that this is a function call. And the function call actually happens in this context right here. And so it'll be outside of the VM, which is pretty cool. So it's like when you access this, it's doing that get call. And so you can, I'm not quite sure if it's an override or if it happens first. Actually, we can play with it. So let's take a look at this. So instead, we'll embed the script directly in our solve script, just so we can play with it a little bit easier. So we're creating a math object, and then we're going to try playing with this define property. So we create a blank object. We call constructor define property. We're able to call constructor this within the VM. So this is outside the VM, but we're able to do this in the VM because the math object would be returned, and this is just a non-proxy object. So anyways, we call the constructor define property math. So on the math object, this A. And so when you do a get on A, it's actually going to return the process. So we can do console.log math A, which will return the process, and then the PID. And so if we run it, we can see here is the process PID. And so the idea is, I think this is overwriting the actual getter. And because of that, it's overwriting the existing proxy object. That's my guess. Maybe someone knows better than me. I mean, people definitely know better than me. But that was the other solution type. So you can use either one of these solutions, either the get prototype of or the define property. They both work as a bypass, and just submit it. So if we actually look, we can go back. Which one was it? Metacalc. Do this. We're going to create an object. Oops, we need an equal sign. Create an object, constructor. Then we're going to do get prototype of. We're going to ask for the prototype of math. Then we're going to go, right now we're outside of the proxy. So then we'll do constructor.constructor. We'll do return process. We're going to call this because we created a new function. Then we're going to go to main module. And then at this point, we're going to require. So we're going to import something. We'll require the child process. This is how we do syscalls. Then we'll do exec sync. Then we'll cat out the flag. Then we'll put this to toString. So let's see. Open constructor get prototype math constructor return process, call the function, load main module, then require, import it, then exec sync, cat out the flag, and then toString. And cool, we get out the flag. So irisCTF, be careful of implicit calls. So this hints what the challenge author thought the solution was. They said that they thought there were going to be many solutions. They were right. But yeah, they thought they were using the define property, which I guess does that implicit call. But either way, cool challenge. It's fun to kind of dig into the internals like that. Thanks.